This is lesson 3.8, solving quadratics by factoring. So far we've just been factoring quadratics and other polynomials. Today we're finding out why we spent all this time learning how to factor. So your objectives today are that you can factor or use factoring to solve a quadratic, and also that you can distinguish between equations that are linear and those that are quadratic, because you only use factoring when you're solving quadratic equations. So let's review a few things, make sure you know these. The standard form of a quadratic is ax squared plus or minus bx plus or minus c. Oops, there we go. Ax squared plus or minus bx plus or minus c. A quadratic could have just two terms, but usually it has three, and the highest degree is 2. So a quadratic expression is an expression whose highest degree is 2. For example, x squared plus 6x plus 8. So quadratic expression, an expression whose highest degree is 2. A quadratic equation is made up of a quadratic expression, so it's a quadratic expression that's set equal to a value. For example, x squared plus 6x plus 8 is equal to 0. So the only difference between an expression and an equation is an equation has an equal sign. A quadratic equation is set equal to some value. The zero product property. Well, in the name you see the word zero, so it has something to do with the number 0. And product means multiply, so it has something to do with multiplication. Here's the rule. If A times B is equal to 0, then either A is equal to 0 or B is equal to 0. So A and B have to be any real number. And yes, if you multiply any two real numbers together and they're equal to 0, then one of them has to be 0. They could possibly both be 0, but only one of them has to be 0. How can we tell if an equation is linear or if it's a quadratic? Well, linear equation is what we worked with in Algebra 1A. A linear equation's highest degree is 1. Here's an example. 4x plus 8 is equal to 12. But a quadratic equation's highest degree is 2. Used all the same numbers. 4x squared plus 8 equals 12. So the highest power is 2. Let's look at some examples of solving quadratic equations. First step is you need to ask yourself, is the quadratic factored? Well, look at the above. Now you might be asking yourself, well, this looks like linear because the highest degree is 1. But if you notice, if you were to multiply this out, you would eventually have an x to the second power, either using your FOIL or stacking. So this is a quadratic, and it's already in our factored form. If it's not in a factored form, then you will have to use one of the 5 methods of factoring that we've learned already. In this case, we are factored. When it is in its factored form, then the next step is that you need to create 2 equations. 2 linear equations, actually. You split it up. So we take one of our factors, I need to get my pen tool here, x plus 3. So when we say is it factored, is each factor there linear? And they are. X plus 3 is equal to 0, and x minus 4 is equal to 0. Then we solve each equation independently. So in the first equation, we would have to subtract 3 from both sides. So x is equal to negative 3. And the second equation, we would add 4 to both sides. So x is equal to 4. So that's our solution. X is equal to negative 3 or positive 4. Or usually we'll just say x is equal to 4. And you'll write like this. So with quadratics, you can have two values that make the statement true. Okay, let's look at the second focus question. Is this equation linear or is it quadratic? It is a quadratic. The highest power is 2. And it's not in factored form. So we need to decide how are we going to factor this. Well, what type of equation do we have here? What type of expression do you see there? Just on the set equal to 0 there. Well, it's a trinomial. We've learned how to factor trinomials, so you need to ask yourself, well, does it have an a greater than 1, or is it a is equal to 1? A is equal to 1, so how did we factor that before? We used our x factoring, didn't we? So we use our x factor. Your a value is the 1, your b value is the negative 4, and your c value is the negative 12. So we put b over c, negative 4, or c over b, my bad. Negative 12 over negative 4. Right, what was the next step we had to do? After we made our x and we put our b and our c value in, then we looked for our signs. What signs should they have? Think about it and write them in. Do you remember if you have a negative over a negative, then they had to be opposite signs, and the bottom number told you which one's bigger? So you should have a positive and a negative. What was your next step? Write your factors of 12. 1 and 12, 2 and 6, 3 and 4. If your smaller numbers are positive and your larger numbers are negative, which pair equals the negative 4? Well, 2 and negative 6 equals negative 4. So write it in factored form. So we're writing the expression in factored form. You should have x plus 2 and x minus 6. Now this is an equation, so you would have to set it equal to the 0. Now we have two factors that are linear set equal to 0. So our zero property rule says that we can set these two factors separately to 0 because we know one of them at least equals 0. And solve for x. So here we subtract 2. X is equal to negative 2, or x could be equal to, add 6, or x is equal to 6. If we were to graph this quadratic, and please see an instructor to demonstrate, show you how to use a graphing calculator to graph a quadratic, you'll see that you'll have an upwards U, and where it crosses the x-axis are your two solutions. So there's that positive 6, and there's that negative 2. That's when the quadratic is equal to 0. When solving quadratics, you must make sure that the equation is always set equal to 0. Otherwise, that zero product property rule wouldn't apply. So we're going to add one additional step to your solving quadratic equations. And the first step is to make sure that the equation is set equal to 0. So you can see in this focus question 3, we have it set equal to negative 7. To make it equal to 0, we simply have to move that 7 to the other side of the equation, or combine it with the negative 63. So just like whenever you're moving a term across an equal sign, what do you need to always remember to do? If you cross the lines, you have to change the sign. So we have to add 7, x squared plus x minus, because they're opposite signs, you have to subtract, and the bigger sign wins. 6 is 5, 13 minus 7, 6, 56 is equal to 0. So that's a 0 pair. So that was step 1, is setting the equation equal to 0. Step 2 is factor the quadratic. Let's take a look at it. Look at the expression that's set equal to 0. How are we going to factor this? It's a trinomial, and a is equal to 1, so this is just the simple x factor. What's our, it's c over b, truck driver, remember? Negative 56 over positive 1. What's the signs of our two values that we need in factored form? A negative over a positive means that the positive number would be bigger and your smaller number would be negative. We need to know which factors of 56 add up to 1. So 1 and 56. I expect them to be my last pair in the set because of the difference of 1. So what are the two numbers that you go all the way down to? Well, isn't it 7 times 8 equal to 56? But if the smaller number is positive and the bigger number is the bigger number is positive and the smaller number is negative, then their sum is positive 1. So I didn't write down all the factors. I just knew that 7 times 8 equals 56, but their difference is only 1. Or the sum of them, if one's negative and one's positive, is the same thing as sum, is equal to positive 1. So in factored form, this expression would be equal to x minus 7 and x plus 8 is equal to 0. Step 3, create two linear equations. So we changed our quadratic into linear equations, x plus 8, and then solve for 0. Solve for x. Plus 7 plus 7. So x is equal to 7 minus 8 minus 8. So x is equal to 8, or negative 8. That means the solutions to this equation is x is equal to 7, or x can be equal to negative 8. Let's take a look at the next example. Once again, you need to make sure that when you're solving a quadratic, it's set equal to 0. Well, if we look, we have x squared minus 15 is equal to negative 7x minus 7. So we do not want those two terms to be on the right-hand side of the equation. You need to move them to the left-hand side of the equation and combine any like terms that you may have. So we need to move this negative 7x over. We'll start off with our x squared. That term stays there. Our standard form says the next term you expect is the x. So we'd have positive 7x. Then we also need to move that negative 7 to the other side. Remember that you need to add that 7. So negative 15. Here, let me write this out a different way for you. Here, that might be a little bit better for you to see. So we had this negative 7x that we needed to move to the other side. The opposite of that would be a positive 7x, and you add that to the other side over here. You also need to move that negative 7 to the other side, so we added 7 and added 7 to the other side. So the standard form would be x squared plus 7x minus 9, because negative 15 and positive 7, those are opposite signs. You'd have to subtract, and the bigger sign wins. Is that right? No, that's not right. 15 minus 7 is not 9, it's 8. There we go. Is equal to, that cancel out, so it's equal to 0. So now we have our quadratic set equal to 0. It's not in factored form, so we need to factor it. This is a trinomial whose a is equal to 1, so we're just going to use our x factoring. Our c is equal to negative 8, b is equal to positive 7. Because the top number is negative, we need opposite signs, and our bigger sign is positive because the bottom number is positive. So we have a negative and a positive. Factors of 8 that equal 7 are 1 and 8. 1 times 8 is 8, but 8 minus 1 is 7. So write this in factored form then. The expression would be x minus 1, x plus 8. And then the final step is to solve each equation separately. So break up your two factors and set it equal to 0 and solve each one. Plus 1 plus 1. X is equal to 1, or x could be equal to negative 8. Do you notice that when you have it in factored form, whatever number is either added or subtracted to x, your solutions are just the opposite? If x minus 1 is one factor, then one of your answers is going to be x is equal to 1. If x plus 8, then the answer is going to be x equals negative 8. So you can just write the opposites. It's an easy way to solve them. Focus question 5 is very similar to the last question we just had. So if you want to try pushing pause and seeing how far you can get with it, then push play and see if you get the same answer that I get. Okay, here we're ready to begin. You had a chance to try doing it on your own. So with the original problem is 6n squared minus 6 is equal to negative 5n plus 5n squared. Remember that your standard form is the ax squared plus or minus bx plus or minus c. We want it to equal to 0. So we need to move this whole side over here needs to be equal to 0. That means you need to move all those terms over. So positive 5n to move it to the other side. I'm just going to write it in between these two terms so I'd remember that that's probably where it's going to go. And this is a negative 5n squared, so negative 5n squared. I'm going to try to write it right underneath the 6n squared. That way I'm ready to combine my like terms. 6n squared and negative 5n squared, those are opposite signs, so I have to subtract. Bigger sign wins. It's just n squared or 1n squared. Plus the 5n, I know that's hard to see, minus the 6 is equal to, and all that cancels out, equals 0. Alright, I have a quadratic trinomial. My a is equal to 1, so this is just an x factoring. C is equal to negative 6. B is equal to positive 5. Because my top number is negative, I need opposite signs, and the bottom number tells me which one's bigger. So I have a negative and a positive number, and the two factors would be 1 and 6. Because 1 times 6 is 6, but 6 minus 1 is positive 5. So the factored form of this would be n, that's our variable, minus 1 times n plus 6. Set each factor to 0, and minus 1 is equal to 0, because what we're saying is if two numbers equal 0, then one of them has to be equal to 0. Plus 6 is equal to 0. So our solution could be n is equal to positive 1, or n could be equal to negative 6. Now you can continue on with your independent practice for this lesson.